So we talked about how to find the slope of a line just from a graph, right, by counting rise over run. And then we talked about how to do it just given 2 points, right? We talked about the slope formula. But now, how about an equation of a line? How can we determine the slope just from like an odd equation? We haven't even talked about that yet. But here's the basic form of a line. This is called the slope-intercept form. It's actually really easy once we get a hang of it. We'll talk about how to graph it eventually. But for now, let's get familiar with the form. Y equals mx plus b. Well, we've already talked about what m is. M is just the slope of the line. Remember which we talked about was rise over run? We even did that formula. B is a bit of a mystery. We haven't talked about that yet. That's the y-intercept. Now remember when we have a graph, right? We have an x and a y-axis, right? So our x-axis is this one. Our y-axis is this one. So it's wherever the line crosses over with this axis. That's what a y-intercept is. Now, how do we determine the slope from a line? Well, literally, we just look at the number in front of the x, whatever that number is. So even if you have something as simple as this, y equals negative 4x minus 1. Well, our slope is literally just the number in front of the x. So our slope would be, m would be negative 4, which again would mean, we'll talk about what that means later, but how to draw it. But that means our slope, our rise is 4, and our run is like left 1, which we'll talk about later. And I'd even like to make sure you know what the y-intercept would be, which is just the number out back, which is negative 1. Easy enough. This even works if you have something strange, like negative 3/4 x plus 5. So in this case, this is still your slope, negative 3/4. That's still your slope. And this back here is still your y-intercept of 5. Now, what if you don't have it in this form? What if it's switched around on you? What if you have it in a strange form such as this? What if you have x plus 2y equals negative 8? Now, this is definitely not in that form. Notice in this form right here, the y was by itself. This one, it's not by itself. So let's fix that problem. So how do we do that? Back to when we did literal equations, I talked about how when you move things around, you're trying to get the y by itself or whatever letter you're trying to get by itself, but you don't get a straight answer. That's kind of what we're trying to achieve here. We're trying to get this letter by itself. So let's work on it, okay? So let's get this x over because we don't want that there anymore. Now I'm going to write this in a special way. I'm going to write it in this order. You could write negative 8 minus x as you read it. However, notice how the x's is always in front of the number here, right? So we're going to leave it like that and then equals that 2y. Now, our y isn't by itself yet, so let's get rid of that 2. Now, how do I do this division? There's different ways people describe it. I'm going to describe it like this. See how this whole thing, the negative x and the minus 8, is being divided by 2? So that's literally what I'm going to do. I'm going to think about negative x over 2. Think of that as a 1 over 2, by the way. So think of it as like 1x over 2. Minus 8 over 2, which was 8 divided by 2, is 4. Okay? Some people even split it up into 2 sets. They say 8 divided by 2 is 4. I'm going to skip that step for now. Now, you may say, this doesn't look quite like the other ones. Notice how this x is right here. If you don't like it right here, you can erase it, and you can actually put it right there beside of that, which is totally fine. So now, look at that. Your m is negative 1/2, and your b is a negative 4. So even though it's not in the same form as these other two were, you can still do the exact same thing as you did before. So let's look at one more strange one like that, where the form is definitely not in the right form. That form is actually called standard form. Standard form sounds kind of nice, doesn't it? But in reality, it's kind of a bit harder to graph it when it's in standard form, and it's a bit harder to determine the slope and the y-intercept if it's in standard form. That's why I like slope-intercept form, because it's easy to tell the slope and the y-intercept. Okay, let's do one more like that. Ooh, let's do a weird one. Let's do a strange one. X plus 5 plus y equals 0. Strange one. Like I said, your y is definitely not by itself. So let's move everything over. Let's move over this x, so let's subtract it from both sides. Let's move over this 5. So we're moving x over and the 5 over. Now you don't need the 0 anywhere. It's just kind of an empty space, right? So this can really drop down to negative x, take away 5, and that equals my y. Now you have it in slope-intercept form, right? But what's the slope? There's not a number in front of x. Well, remember, there's not a number in front of anything. It's always a 1. So my slope in this case, my m would be a negative 1. And my y-intercept would be a negative 5. Okay? Last one we're going to do is also a bit of a strange cookie here, okay? It's going to be a little bit like the one we talked about a minute ago. Negative 30 plus 10y equals negative 2x. Okay? Again, your y is not by itself. We want to get it by itself. So let's move this 30 over first. So we move the 30 over by adding. Now these aren't like terms, so don't get too excited. Don't say, oh, I'm going to add negative 2 and 30. That's not how it works. We're going to leave it as negative 2x plus 30. This equals the 10y. How do you get the 10 in front of the y? You divide. This goes back to literal equations, okay? And this works like the one we just did a minute or two back, right? We have y equals, well, in this case, we'd have negative 2 over 10, which is negative 1/5 x, and then 30 divided by 10 is 3. Boom. Your m is negative 1/5, and your y-intercept, which is your b, is a 3. Just like that, we're done. Now I have a question for you though before we completely head off. I'm going to go back over here. What if you have something that's not there, right? What if you just have y equals 2x and you don't have a b? If your b is missing, think of that as a 0, right? So your y-intercept would be a 0, right? What if you're just missing an x altogether? In that case, think of it as a 0x. So really, you could rewrite something like this as 0x plus 5, right? So in that case, your slope would be 0. So if you're ever missing anything, don't say, where's it at? It's not there, so therefore it's 0. If you're ever missing anything, it's always a 0 for this. That's how we do slope-intercept form, even in different forms, and that's how you tell the slope from that.